So to go over our problems we have here, first one is express this as a decimal. 27 and 34 thousandths. Well, in that statement, the and is signifying the decimal point. So 27 is in front of the decimal point. And we put in our decimal point. 34 thousandths. The way we usually would write out the part after the decimal point in order to make sure we get everything in the right spot is we look at this place value first, thousandths. This is the tenths, hundredths, and thousandths. So our number has to end in that thousandths digit. 34 thousandths, we write in the 34 so that it ends there, and we see that we have to fill in a 0. So 27.034 is how that gets written out. Next, we have Sam, who puts $1.35 in a jar every day. How much does Sam have after 25 days? Well, this is $1.35 times 25. We're just going to multiply it out. I realize many of you will use the calculator, but we're going to do it longhand here. 5 times 5 is 25, so that's 5, carry the 2. 5 times 3 is 15, plus 2 is 17, so 7, carry the 1. 5 times 1 is 5, plus 1 is 6. We'll move over to the 2, so I put a 0 here. I'm going to mark my carries. 2 times 5 is 10, so 0, carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 1 is 2. So we add those up. 5, 7, 13, so 3 carry the 1, and 3. Our decimal point, well, we have 1, 2 decimal places in our problem. So we're going to do 1, 2 decimal places in our answer. So $33.75 is that result. This next one I put up here because, well, it happens in life, and we haven't really done anything like it. Multiplying a fraction by a decimal. To do that, we have two choices. We can either convert all the decimals to fractions, where if they convert easily, that's not a bad option. 1.54 does not convert nicely to a fraction, or we can convert all the fractions to decimals. And in this case, that's probably the best option, to start with that 2 3/8 and convert it to a decimal. To do that, we have a couple of options. We can make it an improper fraction and divide it out, or we can just pull off the whole number and know that whatever we end up with is going to be 2 point something, and then just do the fraction portion to turn into the decimal portion of our result. So 3/8 is going to be 3 divided by 8. 8 does not go into 3, so we add a decimal point and a 0. 8 goes into 30 3 times. 3 times 8 is 24. We subtract to get 6. Add another 0 and bring it down. Excuse me. 8 goes into 60 7 times. 7 times 8 is 56. We subtract, there's 4 left. We'll add another 0 and bring it down. 8 goes into 40 5 times. Nothing left over. So we still have our 2 from our whole number. The 3/8 becomes 0.375. So we have converted the fraction to a decimal. So this is going to become 2.375 times 1.54. This is a little bit of a longer multiplication. 4 times 5 is 20, so 0, carry the 2. 4 times 7 is 28, plus 2 is 30, so 0, carry the 3. 4 times 3 is 12, plus 3 is 15, so 5, carry the 1. And 4 times 2 is 8, plus 1 is 9. We move over to the 5, we put 0 down here, and we mark our carries. 5 times 5 is 25, so 5, carry the 2. 5 times 7 is 35, plus 2 is 37. So 7, carry the 3. 5 times 3 is 15, plus 3 is 18, so 8, carry the 1. 5 times 2 is 10, plus 1 is 11. So 1, and we carry the 1. We move over to the next digit. There's 2 digits to the right of it. which means we have to put 2 zeros down here. 1 times 5 is 5. 1 times 7 is 7. 1 times 3 is 3. And 1 times 2 is 2. 0, 5, 17, 25. So 5 carry the 2. 6 and 3. We have 1, 2, 3, 4, 5 decimal places in the problem. We will have 1, 2, 3, 4, 5 decimal places in our answer to give us 3.65750. Now I realize that most of you have a fraction key on your calculator. If you do and you figured out how to use it, that problem is probably not very difficult. You just do the 2 3/8 times 1.54 and the calculator will spit out either this answer or it might spit out something like, well, what would that be? 263 over 400 or something like that it might spit out. Okay. Any questions off of those problems or the homework from yesterday? So remember, you have quiz 3 that we assigned yesterday that is due today at noon. Of course, today is September 16th. I don't usually stack quizzes back to back like this, but you guys got lucky this time. There is quiz 4 that's out there for today. That's on the decimals. It's due at noon tomorrow. We do it noon September 17th. Like I said, I don't usually stack quizzes on back-to-back days like that, but it just worked out that way this time around. The trade-off is usually it takes some time in class to do the quizzes, so I usually shorten up my lesson to give you time. Today's lesson should be relatively short because we're not taking time out of class to do the quiz. So today we're moving on to an application of these decimals and fractions that I view as one of the most important applications in math. It's actually part of a larger concept called ratio and proportion. And we will do ratio and proportion more formally later on at the end of the semester, depending on the amount of time we have. Ratio and proportion really is the most powerful tool in math. At least 90% of math can be done with ratios and proportions. It's all of your trigonometry is just common ratios or standard ratios, and we use proportions to solve them. All of your rates and stuff like that can be solved using proportions. It is just the extremely powerful tool. If you know how to use it, you can muddle your way through, like I said, at least 90% of math. Well, today we're going to look at one application of ratio and proportion, probably one of the most common one around us, and that is percent. Understand how percent works. We need to understand the word. Percent is actually two words. Per, if you think of miles per hour or miles per gallon or dollars per hour, that means for each or out of. And cent, if you think of years in a century or cents in a dollar, it's 100. So percent literally means out of 100. So if I have 36%, that literally means the ratio of 36 out of 100. In fact, it is that easy, that simple to convert a percent into a fractional form. Now, a lot of places just say convert the percent into a fraction. Technically, this is not a fraction. It's what we call fractional form. If you're asked to convert something to a percent to a fraction, that's what it's asking you to do. Technically, it is a ratio in fractional form. So 36 out of 100 is a ratio. Now, of course, as a fraction, we would not leave it as 36 out of 100. Both of those numbers can be divided by 4. 36 divided by 4 is 9, and 100 divided by 4 is 25. So we would write it as 9 out of 25. Notice I didn't say 9/25, because technically it's not really a fraction. It's a ratio, 9 out of 25. Well, let's look at some other examples of converting percents into fractions. Let's look at 85%. Well, as we said, a fraction is always out of 100. 85% is 85 out of 100. What can both of those numbers be divided by? Well, they end in 5s and 0s, so they can both be divided by 5. 85 divided by 5 is 17. 100 divided by 5 is 20. That's as far as we can reduce it. That reduces to 17 out of 20. So 85% is equivalent to 17 out of 20. We may have something like 264%. First thing we notice, by the way, is that that is bigger than 100%. 100% is a whole thing, the whole amount, or 1. So this being bigger than 100% is going to be bigger than 1. It still, however, is just out of 100. 264% is 264 out of 100. Now, as we mentioned, we see that this is bigger than 1. It's an improper fraction. So we're going to have to, at some point, split it up into a mixed number. To me, it's easiest to do that now because dividing by 100 is pretty simple to do. 100 goes into 264 twice, with 64 left over. Now we can reduce the fractional portion of that. Both 64 and 100 can be divided by what number? They're both even, so we could divide by 2, but we could also divide both of them by 4. So let's go ahead and go for the 4. 64 divided by 4 is 16. 100 divided by 4 is 25. Don't forget the 2 for the whole number there. So 2 and 16 out of 25. Well, we can run into things like this. 36 2/3%. Again, that is simply 36 2/3 out of 100. Now, we do not like having fractions within our fractions. So we need to get rid of that and then simplify this. There are actually 2 strategies we can use to do that. The first one is to look at the fractions within the fractions and look at their denominators. Well, here the only denominator we have within the fraction is the 3. So to get rid of a third, we can multiply both the top and bottom of this ratio by 3. Well, the 100 times 3 is going to be simple. That's just 300. The 36 2/3 times 3 is a little bit more difficult. We have to change 36 2/3 to an improper fraction. 36 times 3 is 108, plus 2 is 110. That's 110 thirds. Times 3 over 1. Now we can cross-cancel the 3's. They divide by 3 to give me 1 and 1. 110 divided by 1 is 110. 1 divided by 1 is 1. So that 36 2/3 times 3 is just 110. Now both of those numbers end in 0, so they can be divided by 10, giving us 11 out of 30. So 36 2/3% is 11 out of 30. The other way we could have done that is just, remember we mentioned that fractions and division problems are kind of interchangeable. We can turn that into a division problem. 36 2/3 divided by 100. Now, of course, we have to make that 100 into a fraction by doing 100 over 1. 36 2/3 has to be turned into an improper fraction. Well, we already did that. 36 times 3 is 108, plus 2 is 110, 110 thirds. And then instead of dividing by 100 over 1, we'll multiply by the reciprocal, times 1 over 100. Now we can cross cancel. The 110 and 100 both end in zeros. So we can divide out the 10. 110 divided by 10 is 11. 100 divided by 10 is 10. 11 times 1 is 11. 3 times 10 is 30. So we get the same result, 11 out of 30. To me, I actually think that this dividing it out is simpler just because it's going to be the same process every time. To do this process up here, you have to figure out what am I going to multiply those by to get rid of my denominators. We might have 56.25%. That's going to be 56.25 out of 100. A percent is always out of 100. No matter what form the percent is in, it means out of 100 if that percent symbol is there. Well, we didn't like having fractions in our fractions. We don't like having decimals in our fractions any better. So first thing we need to do is get rid of that decimal. Now, you might see that it's 0.25. If you multiplied by 4, it would get rid of it. And if you want to do that, that's fine. But I try to take a more standard approach that's going to work every time. And I just use the number of decimal places. There's 2 decimal places here. So to get rid of 2 decimal places, I multiply by 100. 56.25 times 100 is going to move that decimal 2 spots to make that 5,625. Of course, I have to multiply the bottom of the fraction by 100 as well. 100 times 100 is going to be 10,000. Now we do have a little bit of a chore to reduce this. Both 625 and 10,000 can divide by 5, but I'm going to save a few steps by dividing by 25 right away. So 5,625 divided by 25, I believe that's 225. Over 10,000 divided by 25 is 400. Well, we see they can both still be divided by 5, but they actually can both still be divided by 25. 225 divided by 25 is 9. 400 divided by 25 is 16. That's 9/16. So 56.25% is 9 out of 16. I'm going to have you guys try a few here. Let's do 312.5% and 18 1/3%. Convert those two to fractional form. I'll give you a couple minutes. So let's take a peek at how you're doing so far. 312.5% is 312.5 out of 100. Now we do have a couple of things to do here. One is going to be get rid of the decimal place. But this is also an improper fraction. So before I do anything else, I'm going to turn it into a mixed number just because dividing by 100 is probably the simplest spot we can get to turn it into a mixed number. 100 goes into 312 3 times with 12.5 left over. Now we can go ahead and try to get rid of the decimal within this. There's only one decimal place, so I'm just going to multiply by 10. 12.5 times 10 is 125. 100 divided by 10 is 1,000. Can't forget we got the 3 on the front there yet. Well, both 125 and 1,000 can divide by 25. 125 divided by 25 is 5. 1,000 divided by 25 is 40. Again, we can't forget the 3 on the front. Both the 5 and the 40 divide by 5. 5 divided by 5 is 1, and 40 divided by 5 is 8. Still have the 3 on the front. That is as far as it can reduce. That's 3 1/8. So 312.5% is 3 1/8 as a fraction. 18 1/3%. Excuse me. Is 18 1/3 over 100. And I'm going to go ahead and just divide it out. So it's 18 1/3 divided by 100. But this is 100 over 1. 18 1/3 as an improper fraction. 18 times 3 is 54, plus 1 is 55. Then we're going to multiply by the reciprocal, so times 1 over 100. The 5s cross-cancel out. 55 and 100 can divide out by 5. 55 divided by 5 is 11. 100 divided by 5 is 20. So 11 times 1 is 11. 3 times 20 is 60. So 18 1/3% is equivalent to 11 out of 60. Well, let's take a look at converting our percents to decimals. We started out, our first example was 36%. We said that was 36 out of 100. Well, when we look at it like this, it is really simple to see how to convert it to a decimal. We're just going to divide it out. 36 divided by 100. Well, anytime we divide something by 100, all it does is move the decimal point 2 spots to the left. The decimal doesn't appear in the 36, so that means it's at the end. The 2 spots to the left would be to here. That's 0.36. Well, anytime we convert a percent into a decimal form, we have 71%. That means 71 out of 100. The conversion just involves dividing the percent by 100. It'll be 71 divided by 100, which means we just move that decimal point the 2 spots. Now, just like with fractions, the fractional form of a percent was really a ratio, not actually a fraction. The decimal form of a percent has another name as well. The decimal form of a percent is actually called a rate. It's a unit rate. Whereas 36% does mean 36 out of 100, 0.36 as a rate means 0.36 out of every 1. So if I'm converting these percents into rates or decimals, it's a matter of moving that decimal point. 39% becomes just 0.39. 270% becomes 2.7. Only move it 2 spots. 5.6%, well, we still have to move it the full 2 spots, is 0.056. 7%, 0.07. 0.3% can be a little tricky. 0.003, we have to move it the full 2 spots. Now here's one that a lot of people get wrong when I give it to them. How would I convert 1/4% into a rate? Well, a lot of people say, well, 0.25. Well, 0.25 is still a percent. It's just converting from a fractional percent into a decimal form percent. Still a percent, though. It's not a rate yet. To become a rate, we still have to divide by the 100. That becomes 0.0025. I'm going to bring up something here called benchmarks. Remember the first couple of days I talked a lot about estimation and estimating before we punch numbers in the calculator. Here's another spot. Benchmarks is another form of estimation that helps us to avoid some bad mistakes. One of our more common benchmarks is 1%. If I convert 1% to a decimal or a rate, it's 0.01. I can keep that in the back of my mind as I'm doing some of these others, mainly these two. 0.3% is smaller than 1%, which means its decimal form or its rate better be smaller than 0.01. Same is true for 1/4%. 1/4% is smaller than 1%. So its decimal form or rate better be smaller than 0.01. So we can use benchmarks, and we'll show benchmarks a little bit more at the end here today to double check our work and even in some cases to do some simple calculation. Well, if I have a rate or a decimal of 0.41 and I want to convert it back into a percent. Remember, 0.41 as a rate really means 0.41 out of 1, out of every 1. A percent is out of 100. So to make this conversion, if I want to change think of equivalent fractions. If I want to change the 1 into a 100, I multiply by 100. I do the same with the top here, the numerator. 0.41 is also multiplied by 100 to give me 41. So we have 41 out of 100, or 41%. Anytime I'm turning that rate or decimal into a percent, I'm going to be multiplying by 100, which means all I'm going to be doing is moving that decimal point back to the right 2 places. So if I have 0.68 as a rate, that becomes 68%, moving the decimal 2 spots. If I have 0.2 as a rate, that becomes 20%, moving that decimal 2 spots. I have to add a 0 to fill in the spot there. 0.03 as a rate, moving the decimal 2 spots, that is 3%. 2.4 as a rate, moving that decimal 2 spots, is 240%. 0.039 as a rate, again, we only go 2 spots, that's 3.9%. So converting between rates and percents is pretty simple, just moving the decimal point, either multiplying by 100 or dividing by 100. From the percent to a fraction was a little more work. Let's look at going the other way from a fraction back to a percent. And let's start with one that most of us know. We used the same example for converting fractions to decimals yesterday. 3/4, most of us know that that is 75%. But if we didn't know that, there's a couple ways we could go about it. We could convert it into a decimal by doing 3 divided by 4 is 0.75, and then move the decimal point to make it 75%. Or we could think of that ratio. That's 3 out of 4. A percent has to be out of 100. Now here we could just say, hey, 4 times 25 is 100. We'll do 3 times 25 is 75. 75 out of 100 is 75%. But not all fractions are that easy to convert from their denominator into hundredths. If we have 5/8, I want to know what that is out of 100. Well, figuring out what I'm going to multiply 8 by to turn it into 100 is not that simple. So what we're going to do is we're going to work backwards. We're going to do 100 divided by 8 gives us 12.5. So then we multiply 8 by 12.5 to make 100. We multiply 5 by 12.5 to give us 62.5. So that is 62.5 out of 100, or 62.5%. Now this calculation here comes up often enough that we have developed some shortcuts for it. What we multiplied the 5 by was the 12.5, 12.5 here. Where that came from was the 100 divided by 8. And as I said, this happens often enough that we looked for a pattern and then used that pattern to develop a shortcut. Whenever we have a proportion like this, two ratios or two fractions that are equal to each other, if one of the numbers is missing, to find that number, we look at the numbers that we have, there's always going to be two numbers that are diagonal with each other. Those two numbers are multiplied. 5 times 100. And then there's a number that is diagonal to our missing number. We divide by that number. So the process is called cross multiply and divide. So here it would be 5 and 100 are diagonal, so we multiply those. 5 times 100 is 500. The 8 is diagonal to our missing number, so we divide by 8, giving us 62.5. We might have 2/5. Convert that. Well, again, the two numbers that are diagonal to each other are the 2 and the 5. Or, sorry, 2 and the 100. 2 times 100 is 200. The 5 is diagonal to our missing number, so we're going to divide by the 5. 200 divided by 5 is 40. So 40 out of 100, or 40%. Back to benchmarks. I had mentioned these benchmarks a little bit earlier. Let's say that we have a number like 260. That number is 100%. That's the whole thing. Well, common benchmarks are 10% and 1%. 10%, of course, is 10 out of 100, or 1/10. Well, to find 1/10 of something, we just move the decimal point a spot. 10% of 260 is just going to be 26. Well, 1% is 1 out of 100. 1/100th of something, to find that, we just move the decimal 2 spots. That's 2.6. So if I am asked to find 12% of 260, and I get an answer of 24.2, I know right away that that is wrong. Why do I know it's wrong? Well, because 10% is 26. 12% has to be larger than 10%. 12% has to be bigger than 26. In fact, I could actually use the benchmarks to calculate this. I asked you to find 12% of 260. I can actually construct that 12% from the benchmarks. 12% can be thought of as 10% plus 1% plus 1%. 10% is 26, 1% is 2.6, and 1% is still 2.6. And we can just add those up. So I've got 6 and 6 is 12, so 2 carry the 1, drop the decimal. That's 11, carry the 1. I get 12% of 260 is 31.2. Now, obviously, tomorrow we're going to look at direct ways of calculating that without using the benchmarks. But at the very least, you can use these benchmarks in the back of your mind to catch mistakes like this one. Or if you want to, you can use the benchmarks to build some simple percents. For right now, we're going to have you doing some conversions. So your homework is page 79 through 80. 1 through 81, the odds. As always, make sure you do some of each Make sure you're good at the conversions. If you skip some of the easier ones, I'm okay with that. Don't forget, quiz 3 is due at noon today. And quiz 4 is sitting out there due at noon tomorrow. Any questions? Okay, like I said, normally we take class time to do the quizzes, so because you're having to do the quizzes out of class, we'll let you guys go 13 minutes early here today. I'll let you guys get cleaned up and get on with your day if you like. If you do need to stick around for